what's new is should I on my camera?
Yeah, that's fine.
Yeah. So the main agenda of this what's new is about the refactor which we did recently in the Keploy code base. So majorly why this refactor has to happen and what are the changes which we did and what every contributor has to follow. Those will be discussed over here. So the major question is why we needed to refactor. So the main problem which developers face or contributors face while uh, contributing to a code base or anything is majorly like how hard it is to make a code change in a repository or code base. So that has breached to us. So majorly whenever people are trying to contribute or make a change in few particular modules, it was very hard and sometimes even a blocker to a few of the contributors or even to everyone. So really that was the main reason why we came with a plan to refactor the code base so that it would never be such a way that people would it will be difficult to contribute or uh, develop the code base. So let me explain what are the changes that are done in a brief way, and then we'll discuss one by one. So first thing is the if you see the modules which are present in Keploy right now, like before refactor, so those are majorly like hooks, proxy, database, and running the application and command line interfaces. So in previous Keploy before refactor, so the proxy, database, and application related code, everything is inside the hooks only. So it was like one module which has everything, like majorly everything is tightly coupled over the hooks, which actually created a lot of complexity that when one thing has to be changed, like database or proxy or anything, so it caused many problems. And majorly to maintain the like to say key to maintain the context cancellation or maybe like to actually saying key to maintain the uh, mm, I would say it as like uh, the concurrent requests or anything, that was very becoming very hard because it has to go through everything like hooks and then proxy through database. So everything is interlinked. So it was very hard to maintain that. So we decided to decouple them. So the first point is related to that, and the second point is majorly regarding CLI refactoring. So in CLI, majorly there were two things in CLI. One is through command line, which we would be getting the flags and everything, and other one is config file. So we used to manually get the config file flags, I mean config file properties, which are defined in that, and we would again append it to the value which we got from the flags. So that was everything was done manually. So that created a lot of chaos in the repository that everyone needs to do it again and again manually, write the code to extract that particular config variable and attach it to the flag. So that was pretty annoying. And second and most important thing was context cancellation. So if you take the things like hooks, proxies, and databases, they are a kind of Go routine. We run them as Go routines so that it doesn't stop like the execution there. So these all are like server, like proxy is a server and hooks is something like kind of server. We start them, and we also have the responsibility to stop them also. So whenever there is a uh, signal from the user, or if there is any error from one of these modules like hooks, proxy, or anything, we need to stop Keploy. So whenever we stop the Keploy, when the complete tool, we actually need to stop these all other modules manually. So previously it was done manually, and we have to exclusively write the stop functions and invoke those stop functions at the end of the like when we decide to stop it. So we used to use different channels like stopper channel, there are multiple channels we use to like to see where the error is coming from and what else needs to be stopped. Like there were like maybe 5 to 6 channels to notify the error and get it and switch like to know whether the module is stopped or not. So there are many channels to stop this modules which were already activated. So there was very like complex structure to it. So through this context cancellation, we can actually stop, like automatically stop it once we cancel the parent function. So it's like automatic stop. So this is one thing. And fourth is regarding Docker. So this is regarding Docker events. Uh, like we used to listen on a particular Docker event and uh, go through it, but right now we have like going through all the Docker events. And fifth is regarding majorly some like exec calls. Majorly, this is one thing we observed in a repository that we are using it in many places. So exec is nothing but we have to execute is nothing but execute. So it is executing a particular command in your terminal. It's like running a terminal in your code. So that is not a good approach to run something. So we have decided to go through native libraries which are present in Go, which can do the same job. And at last but not least, the GraphQL server. So GraphQL server is basically the previous GraphQL server which we had has a lot of code, and it's not actually a server, but it implements the whole test architecture in itself. So which doesn't invoke the test functions, but it itself has the test architecture. Actually, we use this GraphQL server to expose the test to the other libraries or whoever want to use it as a library, Keploy as a library. So they can actually invoke these calls through these test functions through GraphQL server. So we had to refactor them so that uh, there would be not much code in the GraphQL server. Rather, we invoke the test functions which are already written in the test architecture. So these are major 6 changes which we did. So let me go through the second one, majorly the CLI refactoring thing. So let me show you the code base which we have refactored. So CLI majorly, let me show you one command with which I will explain everything. Coming to Cobra CLI, so majorly you have 2 functions: pre-run, runny, and uh, the general like execution of that command. So first, this part would be running whatever is present in this function, complete function, and then pre-runny would be running and runny would be running. So what generally we used to do previously was we used to manually attach every function over here instead of this add flags, and we used to actually get those flags again, like get boolean and everything, and we used to create the service here itself and we used to run it. But rather than this, because all commands would be doing this, so rather than doing it in every command, we actually decided to create 2 interfaces, that is majorly command service and this service, which actually does the same thing. So it actually takes the command name and which actually adds the flags, validate the flags. So these are the 2 major functions which are there for flags. Majorly what it does is add flags and validate flags, which we internally use here. Let me show where do we use it. So first thing we need to do is add the flags, whatever flags that are present for that command. So we use this add flags function to do that, where according to that command, that particular flags are added to that command. And next in pre-running is nothing but something which is executed before the actual service you want to execute through that command. So here we do the validation of the flags generally. So all the validation of that flag will be done here, or validations like whether he is able to run that command, the authentication or any thing which may come in future could be done over here, which will be done in validate flags. So this also takes command with which it will know per like for this command what validations need to be done. So next comes running. This is the major function which actually the command runs. So this also does the same thing. It will give the command name and it will get the service which it needs, uh, and then we'll invoke the service over here. So let me show you one example like how it is being done. So if we take the example of record, so whenever we invoke add flag and with the command record, it will be like going to this switch case, and it will be having these all common flags which are there for record and test actually. So majorly it's like overlapping. Test has like extra number of flags also. So this is the flags which will be added to that record command. And once we add this, we'll be doing validate flags through the tree running, where the uh, where we actually bind Keploy with Viper. So here comes the topic of Cobra and Viper. So these are two tools which are majorly used for any CLI tool which is present over internet. So majorly what would happen is Viper is nothing but a tool where you have, for a CLI tool, you have many number of configurations, like type of configurations. Majorly, what I meant to say is whatever data you take into your application has many ways. That is CLI, and it may be a config file, or it may be an environment file. To manage these three, it is very hard to manage manually. So Viper is a tool, is a library where it manages all these things, like whether it comes from environment, whether it comes from a config file, or whether it comes from CLI. Actually, it binds everything into one and gives you the chance to take use that one object. So whenever once the all the flags are added, I also have a config here. So let me show the config file. So this is the config file which is used by the Viper to bind everything. So anything from maybe file, or maybe from flags or flags or environment variables, at last it will be binded to these variables only. So that there will be one point of contact to the services or anything. There will be only one point of contact rather than three. So this actually will be loaded in the validate flags. So let me show you the code there. Mm. So when this validate flags is happening, so you can see bind p flags. This is nothing but which actually binds those flags. And if you see majorly this function, let me show you. This is the code where actually it reads the config file which I have given. So here is the config file which I have given, the path and the name of the file and everything. So we have added the flags over here and here, and then we also add the config file, and then at last we will unmarshal the file, and we will make a point where when we make one object where everyone can use it. So here it will be just a minute. Huh. So here it will be done completely. So here you will be getting this config object, which will be loaded with all the values from flags and config file and environment. So the preference would be that flag is given the most preferred preference, so that user, if user want to run something all of a sudden, he'll be most preferred to do it via flags, so that flags are given most important. Like, I mean, CLI flags are given most important, then comes the config file, and then comes the environment variables. So this is how the preference is there. So that if one parameter has three values from different types, like flags, CLI, and everything, CLI will be given most importance. So this is how Viper binds everything into one object, so that there will be no confusion, or manually we don't need to manage those. So this is how validate flags will be done, and other validations, if there are needed according to a command, those will be done over here. uh, and coming to service, so uh, coming to service, it is also done with this switch case, that once a command is given, we will take in the command and we'll get the all the common services. Majorly the common services for record and test are like the DBs maybe, or the telemetry calls, telemetry DB, the and other instrumentation and proxy and hooks, everything are nothing but the common services. So those will be loaded, and the service will be created according to it, and it will be returned to the command CLI, and sorry, the command, and that command will invoke that, but it will check whether the given function is the function it needs, and then it will restart that function, I mean the service. So this is how the CLI has been refactored, so that it actually got modularized, so that there is no duplication of flags or anything over here. If if just think that if that viper or anything is not done, or these interfaces for validate flags or interfaces for this add flags is not done, you have to actually bind, let's say there is a path flag for test, record, and other commands also. You don't have to write it every time over here. So you can just do this add flags, and in the switch case you can handle it. If there are in common, you can combine them into a one case and attach to that flag and everything. And if anyone wants to like declare some other, like use some other interface to this rather than that, they can always welcome to do this. So this is how CLI has been refactored. So coming to context cancellation.
By the way, Charan,
Yep.
have you given an overview of the project structure that we're following now?
No, I'll give it.
I think I'll give that.
Yeah. So coming to the project structure we have right now, that is related to point one key, how we decoupled everything. So previously we used to have a CMD folder rather than CLI folder, where we used to have main.go. But right now we thought the things which are exposed outside, key how people will be using Keploy. Majorly, people will be using through CLI, GraphQL calls. So the all the external uh, like usability that is defined over in this CLI basically. And coming to config, this has all the config related things. The one object which we before talked about, key what the one object which will be used over all over the Keploy, that will be written here. And coming to major thing is like packages. So here previously we used to have hooks, proxy, and other platform types, but we that those were internally coupled. So right now we defined hooks, proxy, the major core things which are done in Keploy into core folder, where you can see you have app which will maintain the app related things, and hooks which related to eBPF connections and everything, and proxy which is related to databases and everything. So outgoing calls and everything. So here, uh, coming to graph is like to expose the test function, the service. The graph is over here, and models is nothing but where we store all see, the major thing why we define models is to avoid circular dependencies. Majorly, like if you have something related to app and hooks and everything, let's say hooks is want to use something related to some structure related to hooks or something, so that can be defined in model so that everyone can use it actually. So this mock mode and Mongo, MySQL, these are all related to everything. Like every package has, like majorly has the import of models. So coming to platform, so generally what are the things which we once Keploy create test cases. So where we dump them, and what are the outgoing calls from Keploy. Those comes in under platform. So majorly that is one of them is telemetry, and one of them the other thing is YAML. Majorly the YAML is the one major outgoing thing which we have from Keploy. So which has different DBs. Let's say the DBs in sense we don't may see it as a DB, but it is nothing but where the test files are stored, where the mock files are stored, where the report files are stored, where the config file is stored. So majorly these, let's think in a point of view that it is not a YAML, let's say it is a MongoDB. You'll have different collections for it and different DBs for them. So that is how you can think to like just view over how it is made. You have a test DB and you'll be having all the functions related to it over here. And coming to services, previously we used to have record test and few other mock record, mock test, and deploy update, and different services. But we thought it a overburden, because the other commands, which are majorly update and version command, or maybe mock record, mock test, like these majorly update and version and few other commands, which doesn't actually require any core operations of Keploy, majorly like starting hooks or running proxy or anything. So we decided to combine them all into tools actually, which has all the commands, all the services, update, and create config file. So these all commands doesn't actually require the core services of the Keploy. So we defined it in tools, and then we renamed the test into replay actually. And coming to the services which actually record needs. So we have defined the test DB, mock DB separately for each service. We did not define like the test DB as one, like test DB interface in the platform, and record and replay using it, because we thought it would be good if the access of the functions to the DBs will be separate for record and replay, so that there will be good ownership to each of them, so that it will avoid many conflicts actually. So coming to utils have all the util functions. Majorly logger is present over here because it is used enormously to all over the Keploy. Log is defined in utils, and these are just other util functions which are exclusively used all over Keploy. So this is how the new refactored folder structure looks like actually. So let me go through the third point, that is context cancellation. So let me show you how the context cancellation is done in one of the service. So let me take the example of record. So coming to record, we have few, like majorly context should be in those functions where it is actually a blocking function, highly blocking function, like it takes much time to run, or maybe like a go routine, which we don't have much control uh, with that go routine, because once you run a go routine, you don't have any like access to it unless you create multiple channels to it. So these are the two major cases where you used to we thought we should use context cancellation actually. So let me show you a few examples where context cancellation is used. So I'll take the example of run command, run function. So this function, this particular code actually runs the application which is given by the user. So whenever we run this function, the application will be ran, and we are providing the context over here. So whenever, let's say, the user wants to actually close the up tool Keploy. So whenever user sends a signal to close the Keploy control C generally, so what we need to do is we have to capture that, and we have to close this. We have to send a signal to this run app to close, with which we will do it by saying run app context cancel. So let me show you where that is present. So actually this run app is has a parent which actually is coming from the original function actually. So this is the context. So once this context is cancelled, so how this context is cancelled is in the utils function. Let me show you. So the context is also in the utils. So if you see the context cancellation, whenever we receive a signal from anywhere, so we actually cancel the parent context, which is given in the main actually. So all contexts which are present in Keploy all over, the this context is the parent of all those. Once this is cancelled, every context which is defined in the Keploy will be cancelled. So let me show you why this is needed. So once you cancel that parent context, this context is also will be cancelled. And if you see this run function, let me show you the run function. So once that this context is cancelled, we automatically given this context to execute library, and that automatically cancels the command, and automatically the application will get stopped, so that you don't have to deal with stopping the application or anything. You don't have to worry about it. So major problems which we got by implementing this context is majorly like two. The first one is it's right that we are implementing context cancellation, but we are not waiting for it. It's like I have given signal for all my processors that you need to exit, but I'm not waiting for like them to completely like get stopped. So that is one major problem which we got earlier, like at the starting stages. So what we thought of using was wait groups actually. So wait groups are usually used for Go routines, where uh, we wait for all Go routines to exit, and then we exit. The main process will exit. So in wait groups, we generally add the wait, and then we actually from the Go routine in the differ function we say ki the wait is done. So it's like adding one to the queue and then deleting that one. So in dot wait function, we'll see once the queue becomes empty, then we will just exit. So this is how wait groups is done. So we thought of implementing this, but rather than this, we got a better approach that is nothing but error groups. So instead of having this code in every Go routine, the wait group, adding wait groups, and in differ function, we are removing the wait. Uh, so and we don't even know the error if we get if there is an error in the Go routine, we don't even know that. So majorly to have a single solution for all of this, there will be a lot of duplication code over here, because in every code you don't want to write you add a wait group and remove a wait group. So there is many point of error. So we thought of using error groups, which actually does it for you. So let me show you an example how it does. So error group is nothing but wait group only. So it does the same function what wait group does, except that you don't have to actually add any wait or remove any wait. And so let me show you. So this is the major line where we define a wait error group. So I have created an error group, and instead of using the normal Go routine, I'll be using this g.go routine. So this is a function which wraps the Go routine, and it actually internally adds the wait group and removes the wait group as the Go routine exits. And we can actually wait in the same way how we are doing in wait groups, g.wait. And we also have externally an error which we actually can get if there is any error which is propagated from this Go routine. Actually we don't have a like method to capture it. So actually this can actually capture it and log it over here. So this is one major thing, to wait till our Go routines or whoever took the context uh, for them to cancel like properly exit and wait till that point. We actually use this wait error groups. So the other thing which we actually got, the problem which we got was majorly synchronization of this context cancellation. So generally there will be multiple functions which are like multiple processes which are started by the main process. But when I cancel the context of the main process, so all the sub process will be received the signal. But imagine that the order is most important thing, because let's say those two services which are invoked by the main process have any connection. If you close one after like let's say there are two processes, one and two. If you close two and then close one, there may be some problems which will be occurring. So synchronization of the context cancellation was very much needed. So what we plan to do was we did was key we actually created the child context manually without taking the cancellation, without inheriting the cancellation from the parent. So whenever we create a child context, we don't take the cancellation function, inherit the cancellation, so that whenever you cancel the main function, the child will not get cancelled. So that we have uh, uh, more uh, more ways to kill it actually, rather than killing it through the parent. We have our own control to kill it, so that we can kill it in an order, so that we don't end up in having errors in our deploy. So this is how context is added and used. So this is the third point. And coming to fourth, fifth, and sixth, Gaurav will explain to you. Thanks, sir. Let me share my screen. Okay. I'm audible.
Yes.
Yep. How do you know he's on?
Because it's my
Hello. Okay. So yeah, so coming to the fourth point, so we have transitioned Docker related operations to like Docker SDK. So earlier we had some operations where we were using command.exec, like exec package, and we were using command function. So in the at there, uh, so we were introducing dynamic dependency. So in some cases, for example, if you want to know which all containers are running, so you will do Docker PS. Rather than using Docker PS in the command, we could use a Docker SDK to avoid dynamic dependency. So the problem with the dynamic dependency is that let's say I have a machine and where I'm using this code, and I'm running that application, running that code. So in my machine, the version of Docker can be different, and in your machine it can be different. So it can cause problems that cannot be debugged easily. So in that case, we introduced Docker SDK rather than going by a Docker CLI. So, and one more thing I would like to add on this point. So earlier in the code base, if I show you, is my screen visible? Yeah, okay. Yeah. So we are listening on these Docker events, and earlier we used to listen on one event called create event of the container, and like we were using for loop, infinite for loop, and there was also obviously some timeout to exit from that loop, but that was not feasible. That was kind of blocking call which we introduced, but and also the need which was for to run the infinite for loop was that uh, we were not getting the information, for example inode or IP or some other information related to the container in one go. So we had to go through like every time to get those information. So but right now we are leveraging start event of Docker container. I'm in Docker. So with this event, we are, let me show you this. Okay. So we are handling Docker events here. So with the help of this event, we are very much sure that we'll get these by after inspecting the container and getting the information, we'll be able to get those information. For example, inode. It is helpful for us to get the namespace PID, which is helpful for the EPF to filter out application, and also we are getting the IP address via this event only. Okay, and what else? And we have also introduced that context cancellation here also, so that whenever, because it's a blocking call, and whenever we get cancellation via the parent, it will also get cancelled, and leaving all the like deallocating all the resources. So another point is, yeah, so same, this point is also related to the dynamic dependency thing. So earlier, we were using dynamic dependency, like, because for example, Docker PS, or in case of exiting from the application, like terminating the application, we were fetching here utils.enter process tree. So here we were rather than using the proc file system, so getting the child PIDs, rather than using the proc file system, we were using some command which created obviously dynamic dependency. But here we are just reading the file system, and the proc file system is nothing but it contains all the information about the running processes. So here we get the parent PID, and we find all the child PIDs from this proc file system and manually send the signal. So okay. One more point I would like to add here is that we introduce context cancellation in the exec command itself. So exec package also provides this another function called command context, and it takes context, and we can define the cancel function, and also there is something called wait delay. Okay, this is something else here. This is wait delay. Okay, so uh, this cancel function can help us to get to send signal to all the process groups. Here I'm saying process group because process group is a group of collection, is a collection of child PIDs. So all child PIDs can have their own process, can share the same process group of the parent. So rather than getting all the child PIDs and sending signal to all the child PIDs, there can be many syscall there. So we are just sending signal to unique process groups. And there's also wait delay, like for whatever reason, if child doesn't get the signal, we are just killing after 10 seconds. And another thing I would like to add here is we are using this set pgid true. So what it does is, like, it creates its own process group. So rather than giving the same process group to the command, we are creating a new process group, and shell will be using that new process group to avoid suicide. Because if we so rather than killing each child PID, we are getting the process group and we are sending signal to the process group. So in that case, if we don't provide a new process group, parent process group share the child process group share the same process group of the parent, so it may get killed. So that's the reason. And also here's one more important thing here, that we are getting the user who invoked that command, because Keploy needs sudo access to run, because APF needs sudo access, but we don't want the application to run via sudo. So we are getting the same user who invoked sudo, and also preserving the environment variables via this command, so that the command ran by a Keploy will get same environment. And yeah, so another point, the GraphQL server. Okay. So as Charan said, there was a lot of coupling and redundant code in the GraphQL server. GraphQL server was initializing DB, test service, and all the stuff. But rather than that, the ideal approach should be the GraphQL server should only start a GraphQL server and nothing else. So here, okay. So here, we earlier, I would like to add here that earlier the GraphQL server was using. So it is helpful for Keploy unit test integration with other languages. We have SDKs in Python, Java, and Node. So those SDKs help us to get each test set coverage which Keploy runs. like Keploy creates, the Keploy creates several test sets for each test run. So you can, for each execution of your application. But here, like earlier, what we used to do, we used to write Keploy. For example, if I am running unit test case of Java application, so what will I do? I will just write ambient test. But to integrate with Keploy, so what we used to do, we used to write Keploy test dash c ambient test dash dash with coverage, or dash dash with coverage. I mean coverage. So that was not good approach, because that that was not even good experience, because it like it was dependent on Keploy to integrate the existing unit test with Keploy end-to-end test. So, but now the thing is, we are just using ambient test, and along with other unit test functions, there will be another function called Keploy test. It will be handling the starting of the graphical server, and it also invokes other APIs to get the test sets and also run all those test sets, and ultimately if, stopping the Keploy as well as application. So, and one more thing, like if you do controls your interrupt by any means, the graphical server and your application will also be stopped without any problem, because we have introduced context cancellation here also. Right now, the graphical server is very lightweighted, because what it does, it just start the application. I mean, the graphical server, and also like handling the graceful shutdown of that server. We have exposed some APIs. Earlier, there were 2 to 3 less APIs here, but right now, uh, starting from hooks, like we can we can start the hooks, like the core package, proxy and hooks from the external environment. So we have exposed that API so that it doesn't interfere with your existing integration test. Obviously, it will not interfere with your unit test, but it may interfere with your integration test. So when the flow goes to your Keploy test function in the unit test file, it will first start the Keploy, I mean graphical server. Then only it will start your core package, I mean start hooks. It will load hooks and start the proxy. Then obviously it will fetch the test sets and run the test set and get status accordingly. And ultimately it will stop the application. And in any case, if there's some signal, any interrupt signal, it will also uh, stop Keploy, and I mean the graphical server as well as the core package and also the application. And another thing, yeah, that's it, I guess. Yeah. Thank you.